my channel. This is another video on Apache Beam code transformations. In our earlier video we have seen few of Apache Beam code transformation. This is a continuation video, right? So on Apache Beam code transformations, right? So as I already told and discussed multiple times in my previous video, right? So Apache Beam is a unified programming model for creating batch and stream pipelines, right? In this video we will concentrate on few of the element wise transformation and also combiners, right, and also aggregations, right. The first thing we will see ToString inbuilt transformation, right. For example, there is a requirement you have performed series of transformation on top of multiple p collections, right. You got a requirement where you will have to write the data into some text file, right. In that case, usually the pipeline would expect a string formatted data to be written into the text file. In such cases, you will have to convert that data into a string format. In those cases, definitely we'll have to use this transformation, ToString, right. You can convert the elements from the p collection to string format, right. So the second transformation is a group of transformation, right. It's a key value pair transformation, right. For example, let's say if there is an key value pair data available in the p collection, right, in the form of dictionary or tuple, right, in case of Python terminology, right. If you have to extract only keys from the element, then you will be using the keys transformation. We have a separate transformation available, right. If you have to extract values, you will have to use values transformation. In some cases, you will have to swap keys and values, right. In such cases, you will have to use KV swap transformation, which is already available, right. And then distinct, it is a same functionality everywhere. If you have to select non-duplicate element from a p collection, then you can use this transformation, right. And then combiners, this is one of the commonly used very important transformation available. We do have a inbuilt combiners, and also we can implement customized combiners by using our Apache Beam SDK provided abstractions, right. So the first one is combine globally. If you have to combine elements within the p collection, globally means you will consider every element from that p collection, all the elements, then you will be using combine globally transformation, right. Then combine PerKey. If the data is or elements are in the key value pair format, you will be using, if you have to combine them based on the key, then you will be using combine PerKey transformation, right. Then aggregation. So aggregation, there are many aggregations available like count, top, right, or sum of element, but in this video we will be concentrating on count, right. So count globally, it is again it is the same thing. If you have to count elements within the entire p collection, then you will be using count globally transformation. Next one, count PerKey. If you have to count elements based on some key, common key, then definitely you will use this transformation. Count per element, actually it looks like count PerKey, but if the data is not in the key value pair format, if you have to count the elements based on the element itself, then you will be using this per element transformation, right. Then mean, arithmetic mean. If you have to perform arithmetic mean, then again it is available in two flavors, that is mean globally, again mean PerKey, right. So globally means you will be performing this main operation on top of every element available in the p collection. In case of PerKey, you will be performing based on the PerKey basis, right. Coming to the demo, again we will see this bunch of p transformation one by one with detailed examples. Now let us go to our Dataflow Apache Beam notebook to see these examples in detail. Okay, so this is the same notebook I've been using, right, from past 3 to 4 videos, right. This has been already created and available for me to use, right. So the first thing we will use ToString transformation. Now you can see I'm trying to create 3 p collection by using different data. I'm trying to create p collection by reading in memory data. If you see this p collection 1, we have data in key value pair format. In the second case it is in the dictionary format. In the third case it is in the list. Okay, so everything is iterable, right? So now we have collection of elements. Now in the first case, if you see, if I have to convert this group of elements into strings, right, then I can use this is in a key value pair format. Then I'll have to use this transformation dot keys. Let me try to print this p collection, how it look like, right? Let me run this. Now you can see everything has been converted to string. Yes, right? So if we have to convert each element into strings as it is, now if you observe this p collection, right, so we have collection of elements in dictionary formats, right? If you have to convert those as it is into strings, right, then you will have to use this particular transformation element. Let us try to see how it look like, right? So right, so now you can see as it is, it has been converted every element, so irrespective of the format, right? So it is in the dictionary format as it is, it has been converted into strings. You can see it is printing as it is like a dictionary, but it is a string, right? So further you can apply some kind of formatting thing to write this data into external file. Okay, so in the third case, so if there are iterable, if the peak element is available in the form of iterable, so all these are iterables, right? Whether it can be a tuple or dictionary or a list, it's iterable, right? Now in the third case, we have list of elements available in the p collection. If you have to convert that into string, right, you will have to use this particular transformation iterable. In such case, what will happen, this will convert this each element as a string with some separator, that is it will use comma for separating these two values available within this element, right? Let's try to print this particular transform p collection, right, and let's see what is the value available, how it look like. Okay, now you can see we have string, collection of strings, right? This is how you can convert elements or key value pairs or iterables available in the p collection into strings while writing the data into a text file, right, or external source. Okay, now let us come to the next transformation, that is key value or swapping key value, right? So in this example, if you see, I have few key value pairs, right? So this p collection has these many key value pairs, right, collection of elements. Now I would like to extract only keys, right, the first case, then I'll have to use keys, right? So let us try to print each of this p collection, how it look like. Okay, now run, you should get only keys, right? You can see all the keys have been printed, fruit doc or something like that. Now if you want only values, right, then you will have to use this transformation beam dot values. Let us try to print that transformation output, right? Now let me run. So now you should see only values, right? Now in the third case, if you have to swap key into value or value into key, then you will have to use this particular transformation. Let me try to print this p collection. Now you should see these two values have been swapped and getting printed, right? So now you should see that output. Okay, now you can see mango has become key and fruit has become value. Like that, every element has been printed, right? So next transformation is distinct. So it is simple transformation where if you have to select non-duplicate elements, right, simply you can see this is a p collection where we have a list of our strings, but we have duplicate values, right? Now if I use this transformation, I could only see non-duplicate values coming up, right? Let me try to run this code. Now you should see only non-duplicate values. You don't see any duplicate value, right? So this is how you can apply distinct, right? Now coming to the combiners, right? This combiner is available in different flavors, right? So like you can combine elements globally, like entire P collection, or else PerKey, or else you can also write your own combiners by using Beam SDK abstractions. Now we'll try to see one by one with examples, right? Now we'll see combine globally. So this combine globally will take some logic to combine elements within that P collection. So that logic can be passed as a user defined function like this, right? Or else you can even use some lambda functionality to perform combine globally operation, right? So in the first case, if you see, I am using this function. So the P collection is this. It is having elements in the form of list, right? What I'm trying to do, I'm trying to read each and every element. I'm trying to combine all this list into a single list using this list summing operation or arithmetic sum. That means it will just add all this list into a single list, right? Your output list look like 1 2 3 4 5 6 7 8 6, right? Within a single list, right? That's what I'm trying to do in this function. Now if I pass this function as an input argument for this transformation, then you should see your single list coming up with combination of all this list. Let me try to print that P collection. Okay, now you should see single P collection coming up. Okay, you can see now all the elements have been added into a single list. Now in the second list, in the second case, I am using lambda function, but if here it is a different example where I have taken sets actually. So this is a set representation in Python, right? So where I have set of elements, right? What I'm trying to do, I would like to just print common values available within each element, right? For example, let's say if you observe these three elements, so we have Dataflow and Spark. These are the two values commonly available across all three elements. Now I would like to print only those values or output those values into some other P collection. Then what I'm trying to do, I'm using lambda function. I've been using set operations available in the Python. I've been using intersection. Then I will be performing that operation. It will print only common values available within each element available in that P collection. Let me try to print this P collection. You should see only those two values coming up, right? So you can see these two values coming up. And there is one more version also available where if you would like to restrict some output based on some logic. For example, I don't want Spark to be printed, right? I will have to restrict that value. You can restrict that value using this exclude class. Here if I specify exclude equal to this value, then it should only print the data flow. That's the only output it is printing, right? Let us try to run this code and print this P collection again. Okay, now you should see only data flow coming up, right? This is how you can use combine globally operation, right? Now let us see how you can implement your own combiners using Beam SDK abstractions, right? So this is how you can do. Beam SDK is providing some base class to implement that customized combiners, that is combine fn. Okay, this is the base class available from Beam SDK. You will have to inherit that class and extend that class, and you will have to overwrite all these methods with your own logic to implement customized combiners. So it is providing set of methods like create accumulator. Accumulator means you will be accumulating the elements available in the P collection based on some logic. So you will be just defining that accumulator, and then you will be performing or applying some transformation on top of each element. So that is through add input, and then you will be merging those accumulator. If there are multiple elements, you will be merging those accumulators by using this method, and then you will be performing some aggregation on top of merge accumulators. Right, here I am performing this inbuilt summation. Right, so if you see, I have in this example I have this P collection where I have 6 elements. So what I'm trying to do, I'm trying to perform squared sum of all these elements. For that I'll have to read each and element, and I'll have to square each and element, and then I'll have to merge them into single list, and then I'll have to apply summation on top of that elements. Right, so I've been doing that using these customized accumulator. Right, let me try to print that final output P collection. You can say this is the 91. Right, if you square 1, 2 and then sum, that value is equal to 91. Okay, this is how you can, this is a very simple customized combiner, but you can implement very complex combiners using this standard templating, right, standard Beam SDK abstractions. Okay, now the same thing can be implemented using these inbuilt transformation as well. So here I have been using customize this combine FN functionality, that abstraction, but here I have been using inbuilt transformation where flat map and then I'll use combine globally and then lambda functionality. So as I already discussed in my previous video, flat map is to, so you will apply some transformation and then it will produce more than one element from the input elements. Right, if you see in the lambda function using flat map, I would like to flatten out all these elements into a single list. Right, then it will become a single list here, 1 2 3 4 5 6. Then by using map functionality I will square each of this element. Right, and then finally I will use inbuilt sum, again the lambda functionality I will use combine globally, so that it will sum that squared element values. Right, the same thing it is doing here. Right, let me try to run this code. This should produce the same value like this. Right, so this is how you can use combine globally. Now combine PerKey. So it is simple thing. So combine PerKey means we should have some common key available in the within the P collection. Now I would like to perform some combine operation like sum, right, or some customized operation. Then I can use this combine PerKey. Here there are two things again. Right, either you can try to achieve this combine PerKey functionality using your user defined function, right, like this, or else lambda functionality. In the first case, if you see, right, so it's a plain flavor where I would like to just do a combine PerKey summation. Right, so then I can directly pass that function value. It's an inbuilt aggregated transformation available where it will just sum up all these values based on the key. If you see, we have AA, then it will sum 3 plus 4, it will become 7, like that BB and also CC. Let us try to print this value. Okay, then you should see summation based on the key like this. In the second case, you can pass some user defined function. Here what I'm trying to do, so I'm trying to do summation of the elements, but I would like to restrict the output. Right, so for example, I would like to restrict that output value to only 7. If that output value more than 7 also, it will output only 7 in such case. Right, so this is how you can use this combine PerKey functionality using user defined function. Let me try to print this P collection, then you should see only 7 across 774. Right, so if you change this value to 6, right, or 4, then you should see only 4. Right, in all such cases you can see only 4. Now output has been restricted using this function. So this can be even achieved to lambda function also. This is also performing the same logic whatever it has been written here. Right, let me try to do that. Let me restrict this to 5 and try to print this P collection. You can see 5, 5 and 4. The maximum value is only 5. We should not see value more than 5 over here, right? This is how you can just combine PerKey. So next thing is count. Count is also inbuilt transformation available to count elements globally or PerKey basis, right? In the first case, I've been trying to count elements based on globally. In second case, PerKey basis, and third case per element. So per element, as I already discussed, if we don't have key value pairs also, it will work well. But here we have been using single P collection for all the examples. So we'll see with the example, right? Now in the first case, globally means you should see the count of all these elements. 1, 2, 3, 4, 5, 6. There are 6 elements, right? Let me try to see that output. You can see 6 as output. Now PerKey basis, right? Now it should count element based on key. Let me run. You can see AA2, BB2, CC3. So third case also per element, it will also produce the same output, right? It will also produce the same output. If you don't have key value pair also, you can use this per element, okay, right? This is how you can use count. The next thing is mean, arithmetic mean. So this is a arithmetic related transformation, right? Mathematical related transformation, where you will apply this mean arithmetic operation on top of elements, all elements within the P collection, or else PerKey basis, right? Same thing, but it will produce only arithmetic mean. Globally means all elements, PerKey means PerKey basis. So simple transformation. Let me try to print each of these element, so P collection with the mean values. Okay, now 2.5. Globally means it will take mean of all the elements. Now PerKey basis we'll see. Now you should see PerKey basis mean values like this, right? Thank you very much for your support and watching this video. We will meet in the next video.